Okay, today I will give some explanation for quiz 7. Question 1. A, tell us frequency. Ask you wavelength. So we know wavelength times frequency equals to light speed. So wavelength lambda equals to light speed c divided by frequency. Light speed c I provided you here in the top of this sheet is 3 times 10 to the 8th power meter per second. Frequency tell you is 2.8 times 10 to the 10th power hertz. So use your calculator to figure out 3 divided by 2.8, which is 1.07. Exponent, don't put in the calculator. So division, just subtract the exponent. 8 minus 10 is 10 to the negative 2. Unit, hertz, cancel the per second. Hertz, actual meaning is per second. Then leftover unit is meter. So since here didn't specify, your answer must be in meter or nanometer. So you can use this as your final answer. Or if you want, you can convert it to nanometer by times 10 to the 9th power becomes nanometer. So 107 times 10 to the 7. 9 minus 2 is 7 nanometer. Some of you convert to nanometer, but didn't get it correct. So the easiest way to confirm your conversion is correct. Whenever you use larger unit, compare meter with nanometer. Meter is a larger unit, so your number will be smaller. Whenever you use a smaller unit, your number will be larger. Okay, this is the easiest way. The B. Here is wavelength 520 nanometer. As you calculate frequency. So similarly, here is wavelength, you can calculate the frequency. So nu equals to c divided by lambda. C is 3 times 10 to the 8th power meter per second. I provided here in the top of this sheet. Wavelength tell you is 520 nanometer. But you need to be careful. This nanometer cannot cancel meter. So we need to convert a nanometer into meter. 1 nanometer, 10 to the negative 9th meter. So now nanometer cancelled. The meter also cancelled, leftover per second, which is hertz. This is the desired unit for the frequency. So use calculator 3 divided by 520. And this exponent is 8 minus negative 9 is 17. Okay. So 3 divided by 520 is 0.00577. Exponent 8 minus negative 9 is 17. This number is too small. Scientific notation requires this number is between 1 and 10. So we need more 3 decimal place. Becomes 5.77. Then reduce 3 here. 10 to the 14th power. This is your final answer. Unit is hertz. Question 2. A asks you how many electrons can be placed in 3D subshell. We know any D subshell includes 3D, 4D, 5D, always 5 orbitals, right? And each orbital maximum can hold 2 electrons. Then 3D subshell maximum can hold 10 electrons. B, ask you number of orbitals in a p subshell. P subshell always 3 orbitals. D subshell always 5 orbitals. Right. Then question 3 asks you the orbital diagram of ground state nitrogen is which one? Give you choice. Row 1, row 2, row 3. So first, what is nitrogen's electron configuration? So nitrogen 7 electron. So it should be 1s2, 2s2, 2p3. Right. Let's write it here. Let's write here. So nitrogen electron configuration will be 1s2, 2s2, 2p3. Other 7 electron. Then orbital diagram should be 1s2, so 2 electron in 1s orbital. 2s2 again 2 electron in 2s orbital in opposite spin direction. 2p3 you have 3 orbitals, 3 electrons according to Honda's rule. So it should be 1 electron in each orbital in same spin direction. So your choice should be row 1. This is your choice. Okay. Then question 4 asks you write electron configuration and orbital diagram for each of the following atoms. So A, calcium. From periodic table, we know calcium atom has 20 electrons. So we can write the electron configuration. So first, we need a chart show how to fill in electron in the orbital. So the chart is 1s, 2s, 2p, 3s, 3p, 3d. The 4s, 4p, 4d. So fill in 1s first, then 2s, then 2p followed by 3s, then 3p followed by 4s, then 3d followed by 4s, then next is 4p, then 5s, 5p, 5d. All right, so we need to understand this chart. Now, according to this chart, we can write electron configuration for any element. So 20 electrons. So first, for sure, is 1s2, then 2s2, then 2p6, then 3s2, 3p6. Only 2 left, so 4s2. Total 20 electrons. Then we draw orbital diagram. So align the electron configuration with the orbital diagram. So you draw one box underneath 1s. Draw one box underneath 2s. There are 2 electrons in opposite spin direction. Then draw 3 orbitals with 3 boxes under this 2p. Fill in 2 electrons in each orbital. 2 electrons in opposite spin direction. Then 3s also one orbital, 2 electrons in opposite spin direction. 3p also 3 orbitals bearing 2 electrons in each orbital. The 2 electrons in each orbital in opposite spin direction. The 4s are one orbital bearing 2 electrons. Okay. Next one is copper. Copper has 29 electrons. Then we can write the electron configuration according to this chart. So 1s2, 2s2, then 2p6, followed by 3s2, then 3p6, then 4s2. You have 9 left. Now you need to realize whenever you see D9, think about take a 1 from its neighbor S becomes D10. The 4S becomes 4S1. So this is a full field, more stable. Okay, special case. Whenever you see D9, think about it becomes D10. Take a 1 electron from its neighbor S. Another special is half field, more stable. So whenever you see D4, then think about it becomes D5. The 1 electron comes from its neighbor S subshell. Okay, so now we can draw orbital diagram according to this electron configuration. So as on the 1 orbital, we draw 1 box. Place 2 electrons in it. Two p 3 orbital. 3 box. Place 2 electrons in each box in opposite spin direction. 3s is on the 1 orbital, 1 box, 2 electrons. 3p 3 orbitals, each orbital holds 2 electrons. 4s 1 orbital, 1 electron. Careful. 3d 5 orbitals, 10 electrons. So place 2 electrons in each orbital in opposite spin direction. So this is a copper. So again, whenever you see D9, so immediately realize you need or 1 from its neighbor S becomes D10. So this is a full field, more stable special rule. Another special case is D4 becomes D5. Take 1 more electron from its neighbor S. Okay. C. Chlorine, 17 electron. So we can write the electron configuration according to this energy chart. 1s2, then 2s2, then 2p6, then 3s2, 3p, only 5 left. Okay. Then 1s is a 1 orbital, 2 electron. 2s also 1 orbital, 2 electron. 2p, 3 orbitals. 3s 1 orbital. 3p 3 orbitals, 5 electrons. Place 1 electron in each orbital first. Then you have 2 more, they must be paired. So place 2 in 2O3. There wants a single electron there, unpaired. Then D is iron, 26 electron. So still use this chart. We can write the electron configurations of 1s2, 2s2, 2p6, then 3s2, 3p6, then 4s2, 20, then left over 6 in 3D subshell. Okay. Then we can write the orbital diagram. So 1s is 1 orbital. Two electron. 2s also 1 orbital, 2 electron. 2p, 3 orbitals. Each orbital holds 2 electrons. 3s, 2 electrons. 3p, 3 orbitals. Then 4s, and 3d, d subshell 5 orbitals. Place 1 electron in each orbital first. This is Honda's rule requires. Then place the last one in any one of these 5, but must be in opposite spin direction. Okay, this is question 4. Then question 5. Here are the 2 energy level of hypothetical atoms. Hypothetical atom 2 energy level. E2 negative 8 times 10 to the negative 19th power joule. E1 energy level is negative 12 times 10 to the negative 19th power joule. Ask you, what is the energy in joule a photon must have in order to excite an electron from E1 to E2? The electron initially in E1 orbital level. Now want to excite it to E2 energy level in the orbital. So how much energy needed? Of course, the energy difference. Right? So the energy needed will be the energy difference between these 2 energy levels. From E1 to E2, clearly E2 is the final, E1 is the initial. So E2 minus E1. Negative 8 times 10 to the negative 19 minus negative 12 times 10 to the negative 19. This is 4 times 10 to the negative 19th power joule. Okay. And then B, ask you what is the wavelength of the photon needed to excite an electron from E1 to E2. So this energy comes from light. Light consists of a photon. The energy of one photon equal to h nu, right? But here ask you wavelength. So we need to use a wavelength frequency relationship. Is wavelength times frequency equal to c. So wavelength frequency equal to c divided by lambda, right? So h times c divided by lambda. Then we switch e with lambda. So lambda equal to h times c divided by e. H is a Planck constant. I provided your value on the top of this sheet. So 6.63 times 10 to the negative 34 joule second. C is a light speed, also provided here. 3 times 10 to the 8 to the power meter per second. Energy, we just calculated, so it's 4 times 10 to the negative 19. So joule cancel this joule. Second cancel this per second, left over meter. So use calculator, figure out 6.63 times 3 divided by 4. So this give you 4.97. Exponent don't need to use calculator. So exponent multiplication is plus, division is minus. So negative 34 plus 8 minus negative 19, which is plus 19. So all together will be negative 7. Unit is meter. You can keep this as your final answer because here I didn't specify the answer in meter or nanometer, so you can keep it. But if you want, you can convert it to nanometer by times 10 to the 9. 10 to the 9 minus 7 is 10 to the 2. 10 to move to decimal place, become 497 nanometer. Okay, you're okay. That's it for the quiz 7. Okay, we'll come back to chapter 8.